Today's the day to make a game. Hello, Joe. Welcome to another GameMaker tutorial. My name is Alex. Let's get started. Today we are going to be doing a lighting controller. Now, if you are familiar with surfaces and their basics at all, then this should be a pretty straightforward tutorial for you. If not, I definitely recommend you go check out my other tutorial on how to create the minute cave effect. And that's a very good introduction into surfaces and different functions we can do with surfaces and how we can use them to create cool visual effects. And this is going to essentially basically be a part 2 to that video where we show how we can optimize this a little bit better and kind of bring this all into one object rather than having our logic kind of spread out in a bunch of different objects the way we did in that video. So as you can see here, we have an example of what the game is going to look like. Now I'm just using an existing project that I'm working on, but you can see the lighting effect here is actually what we're going to be working on, and not only just how to create the lighting effect, but how we can optimize it and just get it really nice, neat, and organized. And we're going to go ahead and start from scratch. So I'm going to have, like I said, I'm using kind of a base framework project to build this on top of, but we're going to do the whole lighting system from scratch. That way you guys can see everything that it is that I go through to do to make this work. So I'm going to go ahead and actually inside of our controller objects, I'm going to go ahead and just delete this lighting controller so that we can start from the beginning together. So the first thing we want to do actually is to create our lighting controller. Now I know I just deleted it, but again, just so we can work on this together and create it from scratch. So let's go ahead and create an object, and I'm going to name this object obj lighting controller. All right, and the lighting controller is pretty much just how we're going to set up our surfaces and where we're going to draw our initial shade, our shadow, where we're going to then subtract our lights from to get that effect. So first thing we want to do is let's go ahead and add a create event. And inside this create event, let's go ahead and just define and create our surface. So I'm going to say surface equals surface create, and we're going to just set this equal to the room width and the room height. Now the reason we're doing this is because we're creating kind of these canopy lights that we saw at the beginning that kind of poke through the forest top, and so these lights are kind of the whole room, the whole ambiance of the forest level that we're in. So this surface is just going to be the size of our room. Whenever we create any sort of data structure, any sort of object, anything that's going to take up any space in memory, the first thing we always want to do is immediately destroy that object. So we're going to say surface free, and we're going to remove our surface. So in any situation in which our lighting controller is destroyed, we don't have this surface floating around in memory. We have successfully managed our garbage. So let's go ahead and create our draw event, and this is where all the juice is going to happen, where we're going to do 90% of our logic. And what we're going to do is we're just going to set up our initial shadow, and then we're going to go through, add little features to it, and then optimize it, and you'll see how we can kind of bring all of our code into this one lighting controller, and it really affords us a lot of flexibility, a lot of optimization, and a lot of simplicity, because then you don't have to start chasing around different objects when you want to create a new effect. So the first thing I'm going to do is I'm just going to go ahead and draw our surface, and we're just going to draw like a nice kind of just dark gray shadow over our whole surface just to give us a dark effect. So we want to say if surface does not exist, our surface, we want to create it. So the reason we do this is because surfaces are volatile, and so if you ever, you'll notice this, that if you've ever worked with surfaces before, when you toggle between full screen, if you have any surfaces that are kind of residual on the screen, they get erased when you toggle full screen, and that's because any sort of resizing of our display and stuff like that really kind of breaks the surface. I don't know all the details behind it, but it's just what we kind of would classify as a volatile data structure. And so because of that, we want to make sure that we always are checking for its existence before we modify it. Otherwise, it could get destroyed at any point, and we're going to get some runtime errors. So we've successfully said surface equals surface create if it does not exist already. And now we just want to set the target. So we're going to say surface set target surface, and all of this is going to look really familiar if we did our last tutorial of the minute cave effect, but I'm going to show you how we're going to change this up in just a moment. And so whenever we set the surface, we want to say surface reset target, And now we're going to draw everything that we want in between these two lines of code. These are going to be the main, this is going to be everything that we're going to be drawing onto the surface. So I'm just going to go ahead and clear the surface right away. That's always a good practice. And I'm going to say, we're going to clear alpha with C black and an alpha of 0. And now what we're going to do, so we've successfully wiped away our surface nice and clean. And now let's go ahead and draw just a shadow over the whole screen. So I'm going to say draw set color, C black, draw set alpha. And I'm going to set this to something large just so we see it right away and we aren't wondering, oh, hey, did this effect work? We're going to just set a really drastic effect so we see it happening as soon as we see the screen load. So then what we're going to do is we're going to reset all of these values back to their defaults after we're done using them so that these residual effects of our color and our alpha don't affect other draw events. So we always want to reset them after we're done using them. And now we've set it, so let's go ahead and just draw a simple rectangle over our whole screen. So we're going to say 0, 0, room width, room height. Perfect. So now, and we have to also define if we want to give it an outline. And we're going to say 0 outline or false. And this will give us a filled in rectangle. All right, so now we've successfully set the target, we've cleared the surface, we've drawn to the surface, and we've reset our target back to our application surface. So now on our application surface, what we want to say is draw surface, and because the surface is the size of the room, we can just set it to 0, 0. All right, so if I go ahead and hit play, you're going to notice that we actually don't get anything drawn to the screen. Now there's a reason why this happened, and part of the reason why I wanted to make this video is to kind of show this bug that I encountered while trying to create this and how I figured out how to fix it. I actually saw a Reddit post, so I can't take credit for it, but it took me a little bit of digging, so I wanted to share this with you guys. So one of the reasons why we're not seeing our surface, even though we've done everything correctly, is because we are using a three-dimensional camera in this game. So if I go ahead and open up my camera object, you'll see that I'm setting up a view and projection matrix. So this is not always done in every project. Sometimes you might have a very simple view or camera setup where you aren't using GameMaker's 3D cameras. However, if you are using a 3D camera in your game, you need to basically force the camera to update whenever you are drawing this surface. I'm not sure the reason for it. I don't know why it happens, but we have to do it. So all we have to do after we have reset the target and before we draw the surface, we want to call a couple functions to just update our three-dimensional camera. So the first thing I'm going to do is I'm going to say if instance exists, obj camera. Now again, if you aren't using a three-dimensional camera, you can go ahead and skip this part, but I just want to cover this real quick. So we're going to say camera set view matrix. And the reason we do this is because in our create event of our camera, we have the view matrix getting set this way. I will link to a video in the description of how to create a basic 3D camera like this. And that way, if you would like to implement it as well, you can follow along a little more closely in this video. Okay, so the first thing we want to do is obj camera. So we're going to set the view matrix. What's the camera we're going to assign it to? We're going to say obj camera.camera. We're going to say obj camera.view matrix. Okay, so now what we've done is we've just updated our view matrix. Now let's go ahead and update the projection matrix. We're just going to call the same function here. And now we need to apply this. So we're going to say camera apply obj camera.camera. So we're setting all of our settings to our camera instantaneously. So if we don't do this, it gets set next frame, but then we've already tried to draw our surface next frame, and we get in this endless loop of it never actually gets fully updated and our surface never gets seen. So by doing this and plugging this in here, we're simply updating our view matrix, updating our projection matrix, applying those settings immediately, and then now we're going to draw the surface afterwards. So if I go ahead and hit play, perfect. All right, so now we have a nice dark shadow drawn all over our room. Let's go ahead and poke some lights through there. So I'm going to come in and I'm going to create a light object. I'm going to say obj canopy light. And I have this sprite created here, which is just a nice long gradient rectangle of a white light. Now you can do this with any light effect that you would like. You can draw these sprites dynamically, but for this example, we just have this very simple faded rectangle drawn. So I'm gonna go ahead and in our canopy light, I'm gonna drag that sprite right in there. And in our main room, we are going to create a new object layer and rename this, we're just gonna call this lights. Okay, cool. So let's go ahead and drag some of these lights in here. So I'm just gonna drag one and we're gonna kind of rotate it and just kind of copy and paste a few of these in here just to get a nice lighting effect. So if I go ahead and run the project now, we should see these lights in here, but we're gonna see immediately that they are part of the shadow that's kind of getting covered, right? So they're in the room, they look okay, right? Like we theoretically could just leave it like this. We could even take out this dark gray shadow that we've drawn over it, and these lights would look okay. But we're gonna kind of take them up a little bit more, and instead of just drawing them here, what we wanna do is subtract them from that surface. Now normally, if you followed our last video that we did on the minute cave effect, I would have gone into my draw event here, and then I would do a couple things like this. Let's just go ahead and do it, and I'll demonstrate why this is not a good idea. So we're gonna go ahead and just draw to it. So let's copy and paste this code because we're gonna borrow a lot of it, and we're gonna delete all this right here. Now the reason I'm deleting this, oops, sorry. So we're gonna delete this shadow because we don't wanna draw the shadow. And the reason we're gonna delete this is because we don't want the lights to clear the surface every frame. We're gonna leave the light controller to do that. So now what we've done is we're gonna say, oh, we need to associate this to obj lighting controller. And we're gonna go ahead and pop these all right in here. And we also don't want to draw the surface because the lighting controller is already drawing the surface, and we don't need to update the camera because the lighting controller is already updating the camera. So what we are doing here is we're basically just saying, hey, this light here, look for the lighting controller, get its surface, and then we're going to draw to that surface. And that's just this surface up here that we've created. So this is kind of traditionally how we would do it. We would come in here and we would say GPU set blend mode, BM subtract, right, and then we would say draw self, and I mean theoretically that's all we have to do. So if we run it, we should see what we did in our last minute tutorial where we just kind of had the objects themselves draw to the surface. But wait a minute, okay, now where's our lights? Now this is the problem with doing it like this, is what happens is we start to split up our draw events all over our different objects. Our canopy is drawing to the surface, our lighting controller is drawing to the surface. Let's say we implement 5 new lights, right? Each light individually draws itself to the surface. What you start to run into is you start to run into issues with draw order not going the way you want it to. So maybe this, maybe the lighting controller draws first and the canopy gets drawn second, but maybe one of the other lights you put in gets drawn before the OBJ light controller, right? So you get a lot of ordering issues, and it's really hard to manually control that order of events when all the objects are kind of split up. Not only that, it gives us less control because it gives us less control over kind of the cohesiveness of the lights interacting together, the lights interacting with the lighting controller. So this gets kind of problematic where we just get this big jumble of code, it becomes messy, and it doesn't even work. So how are we gonna fix this? Well, what we're gonna do is we're gonna take all of the drawing logic out of every light that we create, and we're gonna move it into our lighting controller. The name of our object, OBJ lighting controller, suggests that it is a controller for all of our lights. It's not a shade controller. It's not a dark forestry effect controller. It's designed to be larger than that, to control more than that. And so what we're going to do is we're going to utilize this object that we've created, OBJ lighting controller, by moving all of our draw logic for our lights into this controller object. So now, what does that mean we're gonna do? We are gonna delete everything from this draw event, but we're gonna keep the draw event here, and we're gonna keep it empty. Because remember, if we remove this draw event, then GameMaker will see that it doesn't have a draw event, and it will give it the default draw event. However, if we leave it here, but leave it empty, this will force the object to not draw anything. So we're going to leave it this way because we don't want the light to draw itself. We want the surface control or the lighting controller to draw the lights. Now we use objects because this allows us to then come in here into the room editor and drag our lights around and get the look and a feel that we want. So we want to keep the objects and not destroy the objects either, because theoretically we could just come in here and draw sprites without this object. But by having these objects, it gives us more customization in our room, and we're also going to get the integration of this surface that we've created and optimize it. So how do we do that, you ask? All right, well, let's do it. So we've, let's go ahead and add some comments here. We're going to clear. So this is clearing our surface. Here we have drawn our shadow. We'll just call this forest shadow. So now what we can do is we can start to draw our other things in here. And this allows us to totally circumvent that issue I mentioned earlier of not knowing the draw order or how to customize it, because we are explicitly calling the draw events in the order that we want. So we know that first we're going to draw the shadows. Next, we're going to draw the canopy lights. So we're going to call it draw canopy lights. And I'm going to paste in the code that we had before, and I'm just going to kind of delete some stuff. So I'm going to say GPU set blend mode, draw self, and we don't need to reset this target. So we just need to say with obj canopy lights. And now we're going to wrap all of this code inside of the context of the canopy light that we've just defined. And if we want to be more thorough, we would just also make sure that this instance exists. So we say obj canopy light. Before we try to operate on it, let's make sure that it does exist. Always a good idea. Okay, so now we're saying if that instance exists, let's move our context into it. Now we're inside the canopy light. Let's set the blend mode of the GPU, which is a global property. We're gonna draw our self, which is the canopy light, and then we're gonna reset the blend mode. So now let's go ahead and run it. And here we go. So now we see that it's very similar to our last effect, but the lights do pop a little bit more, and instead of being an additive draw effect on our shadow that we had before, we've now created a subtractive draw effect. But we're going to take this one step further, and I'm going to show you how we can optimize it even more. One thing we can think about is, so the way that the application surface works is that it constantly draws and clears and draws and clears every frame. And this generates this sense of movement because we don't see the last frames hanging onto the surface because they get cleared every frame. Hopefully this makes sense. The reason I bring this up is because our lights are not dynamic. At least currently they're not dynamic. So we don't need to draw the light surface. We don't need to draw the lights to the light surface every frame because we're essentially creating a stamp, right? And then we draw the stamp on the screen. Okay, well, we don't need to create the stamp every frame. We need to create the stamp once and then draw the stamp on the screen every frame. So what does that mean? Well, it just means we need to draw these lights to our surface once to create the surface, and then we can draw the surface every frame. This essentially reduces all of our draw calls. It means that the lights only get drawn once, and then we just draw a new sprite, our surface. So if you have 1,000 lights in your room, well, that 1,000 lights draw call is only going to happen once onto the surface. And then we're going to be drawing just the surface every frame because the lights are static. The lights are not changing at any point. Now, this obviously changes a little bit if we have dynamic lights, so I'll show you how we can do that in just a second. But I'm going to show you how we can maximize our performance with this static light system we've created by reducing the number of draw calls. And it's very simple to do. All we have to do is in our create event, we're going to create a variable called update lighting, or actually we'll say update surface. And we're going to set this true to create because we want the surface to be updated on the first frame, and then after that we're going to turn it off. And all we're going to do is we're going to say if update surface. So if we want to update our surface, we are going to do all of this code. And so that means all we're going to do is draw this code to our surface one time, and then we're going to just draw our surface every frame. So what we want to do is at the bottom of it, we're going to say update surface equals false. So we come into this block of code, we say is update surface equal to true? It is. Let's draw everything to our surface, and then let's set update surface to false. That way, next time we come into this draw frame, we don't actually execute this code, we only execute this code. Because there are so few lights in this project, you're really not going to see a big performance improvement in our numbers. But if you start to implement 100,000 lights of these static lights, doing it like this is going to save you a ton of resources at the end of the day. And you can see that everything looks fine, everything looks great, right? Nothing is broken, and we've got this nice looking light effect. Now, let's say you do have dynamic effects. We can create a very simple script to update this surface and allow us to implement dynamic lights. So in order to do that, we're going to come in here and we're going to create a new script, and we're going to call it update. My fingers were offset. Update lighting surface. And we're just going to run a couple checks to make sure everything exists. We're going to say if our lighting controller does not exist, we're going to exit out of this. And now we can just go ahead and copy and paste some of our code here, right? If our surface doesn't exist, let's go ahead and create the surface. And but remember, this context is to that of the lighting controller, so let's go ahead and drop that there. So now we've scoped our variables to the lighting controller, and so we're going to create the surface there. And all we have to do now is just say obj lighting controller dot update surface, which is the variable we just created, equals true. So if we ever call update lighting surface, all it's going to do is just set this variable equal to true. And then when we come back into our draw event, we will go through and draw all of our lights to the surface again. First, we'll clear the surface so we aren't doubling up, but then we'll draw all of our lights to the surface again. And it will then turn itself off, and it will just wait for us to call update lighting surface again in the future. And then at that point, so if you have a light that flickers, well, every time you turn off that light, just call update lighting surface. If you have a light that's going to turn off or rotate, you can just call update lighting surface. Now, keep in mind, if you have 1,000 lights and you want to update one light, we're going to want to add some more functionality to this so that we're only updating one light instead of 1,000 lights just to change the visual effect of one light. But we can get to that in just a second. Let's go ahead and make this a little more dynamic rather than hard coding this. Let's say you had 100 different lights you wanted to draw to your surface and subtract from your surface. Well, doing this manually wouldn't be that great. So let's come into our create event and let's create an array. We're going to call this our lights. Yeah, nice and original name. And we're going to say obj canopy light is going to be our only light in here. But if we wanted to, we could insert, telephone booth. I don't know why this was the first thing I thought of. Lamp post. OBJ bus headlights. I don't know. I'm just coming up with random things. But the point is that if you had a whole bunch of lights that you wanted to have be part of this surface light controller, then we could just drop them all into an array. And inside of our draw event, instead of hard coding it like this, we're going to say for var I equals 0, I is less than array length 1D, and we're going to say lights. And now what we're going to do is we're going to just say light object equals lights at index I. And now we're going to copy this code here. And instead of checking for our canopy light, we're going to check for our light object. We're going to move our scoping into our light object, and then we're going to do all of our drawing. So we're going to say draw all of our lights. So now if we run it, this will dynamically go through all of our lights and draw them to our surface. Now we only have one light object, so it's not that exciting, but let's say we wanted to do something, I don't know, totally weird. We can just say obj player is gonna now be a light. This probably, I don't know if this is actually gonna work. We'll see what happens. And there we go. Look, we kind of drew our player as a light source to the surface there. And again, because we aren't updating the surface, this only gets kind of stamped onto our surface like one time, and then it just is static. But I could very easily come in here. We're just going to demonstrate this. So I'm going to say if keyboard check pressed, and I don't know, I'm just going to tie it to something P. That sounds good. I'm going to say update lighting surface. So now let's run it again and just take a look at how we can implement this dynamic update we've created. So I'm running, oh, there it is. I hit P. Now I've reset my surface. That's actually a really cool effect that I did not intend on making in this video, but it looks really cool when I press it really fast. Okay, so here, I think that's kind of a good example of what I was talking about, where it just allows us to put anything into this array, and we immediately get full dynamic control over it. We don't have to sit here and copy and paste this code. Saves us a ton of time, and it looks neater. It's way cleaner, and who doesn't love clean code, am I right? Okay, so let's go ahead and try to implement the one thing I mentioned earlier, where I said, okay, let's say you have 1,000 objects in here, times 1,000, 10,000 light objects. Let's say you have 10,000 light objects in this array, and you want to update one of them, okay? So what we're going to do is we're going to come into this update lighting surface, and we're going to add a couple parameters. So we're going to say at param, and we're going to say object index, and we're going to say param clear surface. And I'm going to put a question mark just to indicate that this is a true or false question. So now I'm going to say var object equals argument 0 and clear equals argument 1. So now we've come in here and we've updated the, instead of just calling obj light controller update surface, we're going to also add a couple other variables, and we're going to change some of the logic that we created a little bit. So I'm going to say obj lighting controller dot update surface object. Now this is not a variable we've created yet, but we're going to create it right now. So I'm going to come up to my lighting controller. I'm going to say update surface object equals undefined. And we're also going to copy this line, update surface, and we're just going to call this clear. And we're going to set this equal to false for now, just on default. So now when we come into here, we're going to add some conditionals under these a little bit. So we're going to say clear surface if update surface clear. So now we're only clear if this is set to true, and we're gonna clear the surface and then set it back equal to false. Now what we're gonna do is we're also gonna check if update surface object is not equal to undefined. That means we've specified a very specific object that we wanna update and not just update all of them. We're gonna just do that. So here, instead of drawing all of our lights, we're first gonna check, we're gonna say if update surface object, and just by setting it if this is the same thing as saying not equal to undefined. So I'm just going to say if there is some value associated to this, we're going to update just that one object. Else, if there isn't, well, if we don't have any very specific object specified, then we're going to update everything. But if we do, we want to just update that one. So we're going to copy this, and we're going to call our code right here on this. Now, again, we are starting to kind of block ourselves in a little bit, because then you would have to copy and paste this every single time. So let's make our code a little more dynamic. Let's go ahead and open up this, and instead of this being an object index, we're going to say this is now an object index array. So now you can pass in an array of objects. So let's rename this objects, because that makes a little bit more sense. And now we're going to pass in an object array. Update surface objects. Let's change the name of this to be also objects, indicating plurality. Okay, so now we're going to say if update surface objects and array length 1D update surface objects is greater than 0. So we have some value there, and it is larger than 0. Now what we're going to do is we're going to do the same thing we did here. I'm just going to copy and paste that here. But instead of getting from our light controller lights array, we're going to get from our objects, our update surface objects array. And now this should do the same thing. Update specific objects. So now let's say you want to update only 5 lights in a scene. All you would have to do is, let's go ahead and make our player another light, just for the sake of demonstrating. obj player. And I don't really have anything else in the room that's exciting, so we'll just leave that as is. So now what we could do is when I hit P here, well, we're looking for a couple parameters. We're gonna first come to our script, again, making it more dynamic. I'm kind of all over the place, guys. As you can tell, I only really planned out the first half of the video. The second half of the video, I'm just kind of totally going off the cuff right now, and it's getting pretty wild. But let's go ahead and make these optional parameters. So now the player doesn't even, the developer doesn't have to add these if they don't want to. You have to add one or both, but if the player adds none in there, we're gonna kind of set some default values. So in order to do that, we're gonna say if argument count. And if this doesn't make sense, don't worry about it. This is kind of just extra fluff to make your code a little bit nicer, a little more dynamic, and a little more scalable. I'm gonna be making a video on this specifically in the future. But if the object, so if there is at least one argument, we're gonna set objects equal to our first argument. If not, we're going to set it equal to undefined, and if argument count is greater than or equal to 2, we're going to set clear equal to that parameter. And if not, I think we want to default, we're going to default clear to true. Yeah. And I hate the way this looks always, so I'm going to wrap this in a region, and I'm going to call this arguments. That way I can collapse that region, and it's going to look nice and pretty. So, okay, so now this call right here, if I close this out, this call right here with no parameters is totally valid. And we can call this, and it will default it to no specific objects, and we won't clear the surface, or we will clear the surface. So this will just do everything that we had done up to this point already, the same way. Nothing has changed. So here I press P, we update all of our lighting objects just the same way we would have in the past. But now if I want to, I can say we're going to pass in an array here, and I can just say obj canopy light, and I'm going to say this would actually be cooler. We're going to say obj player, because that is our light. And we're going to say, will it not clear the surface after, when we update it? So we're just going to update the surface with our obj player light. And, but we're going to keep the old surface there. So if I press, okay, so to fix that bug, GameMaker didn't like that I had just update surface objects. Because it is an array, it doesn't like that value type. So we just have to make sure if update surface objects is not equal to undefined, and we have some items in there. So now if I run the game and I press P, you can see that we are creating new stamps. Now we are losing everything beforehand because every time we call update surface and we aren't clearing it, we also redraw our shadow, our shade, like our canopy shade effect on there. So if we wanted to, we could come into our update surface, we could create another, we could say param update shadow, and that's going to be some questionable optional value, and we're going to update our argument count collection. And we're going to say if argument count is greater than or equal to 3. And we're going to create a new variable. We're going to say update surface shadow. And we're going to set that equal to false for now. Now, if the player doesn't enter a parameter, we're going to default to updating shadow. Yes, yeah. So we're going to say if update surface shadow. And now if we go ahead and we need to update our step event where we call that. So when we update lighting surface, just for the sake of demonstrating the dumb things we can do, we're going to say don't update that shadow when we call update surface. So now we're just going to update the player object light that we've created. And so if we run, oh, what are we doing? Oh, we have to set that true by default. So yeah, we actually want these to be true on creation. That way it actually gets executed at least once to set up our scene, and then we can erase it later. Okay, so cool, we've done this. And now you can see we can stamp our player all the way through here. And this actually is a really cool effect that I don't even know what we would call this effect, but I like it. Slow motion stamping, we can do that too. So yeah, I think that's everything for this video. I went way overboard. I got super distracted. So anyway, guys, thank you so much. I hope you enjoyed the video. I hope you found it useful. I know that I tend to be very distracted and code in what seems like very kind of tedious ways. You look at all this and you say, Alex, why would I do this? I have to type so much more code. You're doing all this extra stuff. I could just hard code this. It's so much easier. But when you look at this from a long-term, big picture perspective, these types of functions that we're creating, these type of code that we're creating, being highly optimized and highly organized and well designed is designed for you as a developer to make your life easier at the end of the day. Now, instead of having to go ahead and copy and paste and hard code all this stuff, I can just tweak a few values here, add a few variables there, maybe add a new item to my list here, and everything becomes so much easier to use. So I hope you guys enjoyed. If you liked it, please like the video, subscribe, follow me on Twitter. I'm posting updates everywhere. If you want to support the channel, there's links in the bio. I'll also link to some of the other tutorials that were great in helping me get to this point of understanding. And I will see you guys in the next video.